This video is based on Introduction to the Qualitative Analysis Technique. Now, this table shows a overall summary of what's going on in order to perform this particular lab. So look over here, there's silver, copper, and iron. All of these three components are going to be in one test tube. So I have a test tube here with all of those three components here. Our job in this particular lab is to separate the silver, the iron, and the copper to they're currently in solution like this. You can't see them. They're not solid. They're in aqueous form. And somehow we want to take one out at a time, an iron and also copper, one out at a time. And to make this contaminated, let's say it's a contaminated water with silver and iron and copper, to kind of get rid of every of these components. So that's sort of our goal. But no, you will see how these have series of steps. Each individual line that goes down represents you're adding in some kind of component. Why do you add those components? For example, when you add as HCl, that chlorine is going to react with silver. It's going to react with silver, and it's going to cause some precipitation to come out to form a silver chloride. Here, in other words, if I were to add in HCl like this, right? I'm adding in HCl. This Cl is going to react with the silver. Okay, it's going to react with silver, and what's going to happen is it's going to form into a solid, and it will sink down eventually. And all of these solid will just sort of remain on the bottom, whereas this is still free floating. Then we can separate the solid with the liquid. Then, and I'll show you more in details how this goes about. So that's what's representing here. You see that the silver chloride is separated from the copper and the iron. So you will, after decant this, meaning you will take this out, and you will be just left with the pellet here or the precipitant on the bottom. When you have just these two left here, thioacetamide will be added. And say, for example, this is thioacetamide, and that's going to react with, in the beginning, it's going to react with the copper. So here's copper, and it will form black, and it will sink to the bottom. Okay. Then we separate these two, and so this goes away. So, and then next one, here's another thioacetamide. That's going to react with the iron, like this. And then this will sink to the bottom, okay? Now you'll have three separate tubes with iron and silver chloride, copper sulfide, and iron sulfide. You'll have all of these three in solid form. But how do we know those are truly silver chloride, truly copper sulfate, and and iron sulfide? Well, for silver chloride, it's going to be white precipitate, so that's how we concluded. For copper sulfide, we actually add in acid and pull out the copper back out, and then react it with ammonia to form a copper ammonium complex, and that will show a deep blue color. That will indicate that we do indeed have copper. Or whereas over here, the iron sulfide that we have, well, you're going to add in potassium thiocyanate in order for it to form a complex ion, and this ion is orange and red, and so we can tell that this is truly an iron in there. So let's go over each procedure step by step of what's going on. So I'm going to go over procedure A in the first part of the video, then I'll go over procedure B, then C. So let's go with procedure A, where in which we are trying to get silver chloride. So in the very beginning, what you're going to do is you're going to grab a small test tube. There's a 3-inch one and a 6-inch one. You want to grab a 3-inch one. This one is the small one. And you're going to drop 15 drops of silver copper iron mixture. So you will take silver, iron, and copper mixture. So they're all in one mixture, and then these go in, okay, in dropwise fashion. Then what you're going to do, you're going to take 6 molarity of hydrochloric acid, and you will add that in dropwise. You're going to add in hydrochloric acid in, okay? And then you will drop in until the precipitation occurs. So you drop, you give it a little shake, drop, and give a little shake to kind of mix. And eventually what will happen is that this chlorine will start to react with the silver. And when they do, you will see some kind of murky liquid forming. It's no longer clear. Then what you're going to do is you're going to get another 3-inch beaker. Oh, I'm sorry, 3-inch, not beaker, test tube. Okay, so I have 2 test tube. And there you're going to be adding water on this side. So you add water. So let's pretend this is water right here. So you're going to add water in here, and the level of here should exactly match over here. You can also place this in the balance in order for it to equal in weight. Okay, by grams. So if you have an equal amount, we can take this to a machine called a centrifuge. So let me show you an image of a centrifuge. So we have a centrifuge that looks like this. The machine looks like this or like this. This one's a little older model, but you see there's these holes here. This hole is where the test tube is going. One side is going to be the water, and the other side is the sample that you just added hydrochloric acid to. And why am I doing this? Well, once it's in the centrifuge like this, there are counterparts of each other, and it's going to start spinning. This is going to spin like spin, 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 spin. It's going to spin. And as it spins, the heavy stuff, like the silver chloride, are going to sink to the bottom, and they're going to all silver chloride will sink to the bottom. Whereas the iron and copper, they're not in solid form, so they'll still float around. Water also just floating around as well, but this will sink down. We will then take it out of the centrifuge, and let's leave this one to the side. And this one, we'll go ahead, and what we're going to do is decant, separate the liquid portion versus the solid. Now we do have to put in a fancy word. This is now the liquid portion is called the supernatant, and this pellet on the bottom it'll be called the precipitate. So supernatant and the precipitate. I'm going to take a pipette. It'll be a plastic pipette that looks like this. You can just pour it out like this, but best to get a pipette and then take up the supernatant portion, which is the liquid portion, and it's going to get sucked in here. And then go ahead and pour it out into another clean test tube. So this is, you might want to label iron and copper ions. You're going to put it in here, okay? And then once you put it in here, you're going to squeeze it out, and then now you have your copper and your iron supernatant in here, and you have your solid over here, right? Now this right here, you're going to go ahead and wash it with some DI water. So I'm going to take some deionized water and wash it. And then what you're going to do is don't just put it in and that's it. You're going to stir well with the stirring rod. So here's my stirring rod, and I'm going to mix. So this is sort of like, I'm going to fly around a bit, okay, right? Because as I'm stirring, okay, this is my stirring rod, by the way. So I'm going to leave these two to part B, and I'm going to go continue to stir, and then I'm going to centrifuge again. Okay, I'm going to centrifuge with another test tube that has, you're going to have to make sure that it is balanced like this. Let me take my stirring rod out. I'm going to take another test tube, put an equal amount of liquid water on this side, and then centrifuge it so that it spins around again. Okay, spin, spin, spin. Then the silver chloride will sink down, right? And then the water or the supernatant will be just floating on top. Then you're going to discard the supernatant, meaning take your pipette, right? And you're going to take this up. It'll just be water, right? Maybe some other residues in there. And then you're going to pour it into the waste. Sorry. Here's my waste beaker. And then just pour in the water in there. Okay. All right. So you're just left with silver chloride, and you will make your observations here. Your direction might say go to the instructor. You don't need to come to me. You just need to make observation and take an image, and that image will be part of your data.